The claw machine build is complete, but we still have to talk about the firmware. Hey everyone, Chris here, and hopefully you've already been able to use your Candy Claw machine as is. You could take the files I already had and use them on your project. But if not, and you need to make some sort of custom configuration, this is the video for you, because today we are going to run through all the firmware tweaks I did to make all of this work. Now this is straight up Marlin out of the box. I don't have to do anything really tricky inside it to get it to do what this machine does. You just have to enable and configure the features that you need for joystick, buttons. There's a handful of things, but it's all there. Nothing outside of the scope of just enabling a few features here and there, and you'll be up and working. I'll show you how I get all of that done. So let's jump right to the computer and we'll look at my configuration. All right, here we go. So this is version 2.1 of Marlin. There are newer versions out right now. Any of the newer versions that are out are going to support all the features we need for our Candy Claw machine. Now this is configuration.h. You're going to have to make changes to both files, but in configuration.h, they're pretty minimal. We'll try to keep track of the line numbers here so you can go through my config. It might be different in versions of Marlin, but hopefully it'll be somewhere close to the same line number. They do change things up quite frequently. First thing I would suggest you do is rename your configuration just so you have some notes. I have named mine and the first time that I build it. You can always add boot screens depending on the screen you use on your machine. I didn't do anything custom here. And by default, Marlin is configured to use a ramps board. I didn't even have to change the board since I'm using ramps. But if you are going to change it up, you're going to have to change this, as well as some of the serial options if you're not using an 8-bit board. Something like a Big Tree Tech board, you're probably going to have to use a -1 for your serial port. But since we're using ramps, no changes needed. Baud rate, you can pick 250,000, that's the default. That'll work just fine for this configuration. And custom machine name. You can call your Candy Claw machine whatever you'd like, but that will be on the screen. I think that's a nice touch. Next up for the drivers, if you're using A4988s, those are the default, and we just need 4, X, Y, Z, and E. But again, if you're using something different, you'll update it here. No changes for me. Next up, we have thermistor settings. We have a Candy Claw machine. It's not a 3D printer, so we don't have thermistors. But the software will error out if you don't have one. So you have development options here, 998 and 999. By default, 998 sets you at 25C all the time, 999 at 100C. You can also change that up if you'd like a different temperature. I just plugged in 998 to get around it. My machine is always setting at 25C. This isn't something you'd ever want to use on a 3D printer, but this machine, it's perfectly safe. And bed is set to 0 by default, so we don't have to worry about that either. Down below here, if you'd like to change the default value for those two dummy thermistors, you can do that on these two lines. Next up, a couple of safety features we do not need for a Candy Claw machine and will cause you issues if you leave them intact. That is prevent cold extrusion. We're always going to be cold. We're never going to heat up. And extruder min temp. I just go ahead and shut that off. We are always going to set it 25, but we don't need to test that in this claw machine. So I just commented it out. Then down here, prevent lengthy extrude. We are going to want to be able to extrude as much as possible because the extruder is now the mechanism for the claw. Not that we'll ever hit this amount, but go ahead and comment it out anyway so that you can use it as you see fit. We don't have to worry about max extrusion. As well as extrusion length. By default, you can only do 200. We don't care here, so we're going to comment that out. So all 4 of these options, just put a / at the beginning, and we don't need them. Then we go to end stop settings. We do use X minimum on the Candy Claw machine. We do not use Y minimum. We use Y max. So just comment the Y min out. And we do use the Z min plug. So leave that intact. And then down here, take the comment off of Y max, because that's how the end stop is configured. Normally it would be in the back of the machine where Y0 was. Ours is in the front. End stop inverting, for the end stops that I'm using, the ones on the red PCB, you want to make sure that those are set to true. This could be different based on the brand and type of end stop you use. use the M119 to test this, but all three X, Y, and Z for me were true. I just set the Y min to true because I wanted them all to be the same. We're not actually using that. We have to use Y max. I set that one to true as well. Just make sure you update this or you're going to collide because the end stop won't trigger correctly. End stop noise threshold, I went ahead and took the comment off of this. It's not going to hurt anything. I just left it at the default of 2. This is just to make sure the end stops are consistent. Some of these PCB end stops can be a little dicey. This should help you out to make sure it's confirmed that that end stop is getting triggered correctly. Default axis steps per unit. So we are using 20-tooth pulleys both for drive and idler for X and Y. So I set both of those to 80. We're using 1.8 degree motors, 200 steps per revolution. This is the correct math for those type of pulleys. Now for Z, I set this up just a little bit different. I took a guess based on how large the pulley was that actually pulls the string up for the claw. This is going to be different based on the amount of string you have on the spool because it's going to grow and shrink. 600 is a fine number. I prefer to adjust the travel rate with the button press. You'll see that when we get to the other file. I just leave it at 600. If you're using a 1.8 degree stepper, this is going to be a fine number. And then for the claw or the extruder, I went with 60. I did the low number because I wanted to use a higher count number when I was telling it how many steps to move to open and close. I had it at a higher number and it doesn't seem to like it in the firmware when you tell it you only want to move 1 or 2. That's in millimeters. It likes it much better if you tell it you want to move 15 or 30. So I set it pretty low right here at 60. Play around with these numbers, but if you use my design, these settings should be just fine. Then feed rates, I wanted to slow them down since we're using this joystick. It goes as fast as it possibly can go, and it's way too fast. So I set these down quite a bit lower. 300 X and Y, 400 for Z, 300 for the extruder, or the claw. Acceleration, same way. I left it at 2,000 across the board. It allows it to move fairly quickly, get ramped up pretty quickly, but not excessively. And when you're setting acceleration, you want to make sure you're setting travel and default because that's going to be impacted. These are the settings when you're not printing. We do start the print clock, so both of these will be involved, but this is the main one that you're going to use while you're moving the joystick around. So make sure you adjust them all. Next thing we need to update is the step direction, which way the motor turns. I tried to keep these fairly consistent. With ramps using the DuPont connectors, it's really easy just to flip the cable over to change the direction of a motor. So I just kept these the same at all times and flipped it at the motor side if I needed to. So I set all of X, Y, and Z to false, and I just left the extruder motor true. So adjust those if you need to. I did enable no motion before homing and home after deactivation. This keeps the machine from doing anything on button presses when you don't want it to. The tricky part of this whole thing was not being able to hit start while the machine was in motion and not being able to hit claw after we hadn't gone back home. These two settings will help regulate that. In fact, these actually make how I configure the machine possible. So you definitely want to enable these two. They're not enabled by default. Next up, home direction. We are using the Y maximum, so you want to change your home dir to 1. If you're using minimum, you use -1. So X and Z, totally fine. Y, had to change it to 1. Then bed size. This is what keeps it from colliding in the X and Y direction. Mine is actually just a little bit bigger than this is right now, probably around a 305 on the Y. I was able to move some of the parts around and get a little more travel. So the version you have will be updated, but just note this is what keeps you from colliding left and right on the machine. The claw doesn't make it all the way to the back of the machine, but it's really close. And then with Z, I set it to 500, just so I had enough area to move that claw down and up as I saw fit. It's nowhere near 5 capacity as far as we have our steps set up above. We have it set to 600. but I just put in a really large value so we'd have room. The next thing that I adjusted was the homing feed rate. I wanted it to go just a little bit faster than a 3D printer would while it was homing because the user has to wait for it to home before they can play again. So it's set at 50 times 60 for default on X and Y. I just jumped it up to 70 so it'd be a little quicker. As well as Z, it's set to 4 by 60 by default. I moved mine to 6. Again, just so it'd be a little speedier so more people could play faster. Then we get down into the LCD settings. I did enable slim LCD menus because we don't need them for this configuration. You don't have to do this, but I thought it was a little simpler. If we don't need it, I'm not going to enable it. So I went ahead and took the comment off of that option. I also removed the comment off of reverse encoder direction. That's just a personal preference. I like clockwise to be down, counterclockwise to be up. Speaker, this enables you to be able to use the buzzer. I like to play tones depending on what the machine is doing, so we enabled that. And I am using that 2004 display, which is the RepRap Discount Smart Controller, so we enabled that. Again, you wouldn't even need an LCD for this, but since I was trying to keep it like a 3D printer, I thought it was a nice add-on. And that's everything in configuration.h, but we have a lot of work to do in configuration_adv.h. Alright, configuration advanced. Here's where all the fun stuff is. We'll scroll on through. Around line 837, this is the first thing you're going to want to update. For your Candy Claw machine, you don't want home bump. That's when you hit your end stop, it backs up a few millimeters, and then hits it again to check it. We don't need that for this machine. So all of your home bump millimeters, set all of those to 0. X, Y, and Z. And then back off is the same way. That's how far it backs up before it hits it again. All those need to go to 0. And we also want to take the comment off of home Z first, because we want to make sure the claw is out of the way and homed and up before the machine moves around. You don't want to drag it around the bottom of the machine. So that's a critical one. Make sure the comment's off of that. Next up, disable the steppers. Now, all of the rest of them, X, Y, E, that's fine because we're spring-loaded and that jaw should always be closed, but not for Z. We want to leave disable inactivity Z set to false. If you don't, your claw will crash after the timeout value, 120. Now, the Z can be set to a relatively low current value. My current reference voltage is about 900, but since it's just sitting there inactive, they're fairly large motors, that's not going to cause a lot of extra heat. So you don't have to worry about that. Plus, you should be using PETG. They can withstand a little bit of heat from that motor. So everything else can stay true. It's fine if it times out, but you have to leave Z on, or it's going to crash into the bottom of the machine. The next section we have to tackle is the fun section. This is the custom buttons. So you can use your start button and your claw button. Now, I have a few things in here that I've used for testing. Anything that's got the defined button commented out, just ignore it. You can use some of my examples for your machine if you want to, but in my config, I'm using button 2 and button 3. You can have up to 25, but make sure this line up here, the define custom buttons, has the comment off of it, and then uncomment the buttons you'd like to use. Now, I'm using pins 42 and 40. You can see those in my really crude diagram that it's going to be on the GitHub, but you can also compare that to ramps or whatever board that you're using. If you take a look at the ramps pinout, here's 40 and 42. That's where we put our yellow and blue wires that are going to control the buttons. You remember that from previous videos. Button state, we are triggering to ground, so we want to make sure both of these are set to low. That is the default state, but make sure that's updated. And then when printing, you want to make sure these are set to false. This is a critical thing on how I've set these up. They can't be active while the machine thinks it's printing. So make sure both your buttons are set to false. And I'll tell you why in this G-code command that we're going to use right here. So after that, when you set up a button, I have a whole video on how to do this, but when you're setting up a button, you just list all the commands you'd like to run when that button gets pressed. And depending on that command, that's what the machine is going to do. For instance, if you run some commands, then run a G28, that G28 is going to have to complete before it continues on with the rest of the commands. And that's how I've made these buttons work correctly. The key being M75 and M77 here at the end. M75 starts the print counter. That tells Marlin and the 3D printer that now we are printing. So that blocks out the buttons. So after you press it, it automatically goes to print. You can't press another button. That's key to being able to let your machine work correctly. So this is the start button. The first thing I do is set that print counter with the M75. Then we do an M92 to set all of the E-steps for all the motors. I threw this in here as kind of a catch-all. If you wanted to set them to 0, that would also stop the machine. But I wanted to make sure I reset it at the start of every one so it would be correct. Then I G92 E0. So I set the extruder, I tell it that it's on step 0. It hasn't advanced at all. Then we G28 to go home, to home all the axis to get ready to go get the candy. Then I tell the extruder to go backwards, -3. That allows that extruder wheel that has the wire on it to go back and hit that 10mm screw and error out. So basically it's causing the motor to skip, but now we know we are at that 10mm screw, so we know how far to advance that wheel to get the claw to open. You don't have an end stop for your extruder, so you can't tell when it's at 0. This will ensure that you've errored out, you've went all the way back, and you're at that screw ready to move forward. After we've bottomed out on that screw, we go back to 0, because now we know we are at 0. Then I play a couple of tones. That's what M300 is. On this one, I'm just playing 3 tones. If you want to play around with this, I suggest you create a G-code file and just run it over and over until you get it set up correctly. They're pretty annoying, but it's still good to know when the machine's ready. So I like playing the tones after my sequence is complete. And then when those tones have completed, we do an M77 to stop the print counter. We stop it at this point because if you didn't, it wouldn't allow you to do your next button press for claw. Because they're set to false. You can't use them while you're printing. So now you're moving your joystick around, you're trying to find the candy that you want. When you do, you hit the claw button. And that's this sequence right here. So again, we start the print counter with M75. We make sure the extruder is set to 0 because now we need to go forward from that amount. This is where you're going to have to play with it just a little bit. With my design and the steps that I've given it, I found to set the extruder to open the jaw to a reasonable amount without skipping, I do E13.5 at a feed rate of 250. That opens it pretty wide so that you can grab pretty much anything that you'd ever want to put in that machine. So it opens the claw, then it lowers Z down 40. You're going to have to play with this number a little bit too, based on the length of the string and how much you have wrapped around that pulley. For mine, dropping Z, the amount of 40 at that 600 step count, gets me right over the bottom of the machine. You don't want to go too low because whatever you have in there, it's going to crash on it. This is based on an empty machine. It stops about 10 millimeters from the bottom. So adjust that according to how your build goes. But this is where you want to play with these numbers on the button press. So now Z is down 40. The claw is open. Then we send an E0 to close the claw, hopefully grabbing whatever you wanted. Then we just do a G28, and we have to home Z first. We saw that setting earlier. So Z goes up, then it goes to X and Y. The X and Y position, when it's at home, 0, 0. Actually, the Y would be 280 because it's max. That really doesn't matter. But when it goes home, you're going to be over the candy well. So now we're going to drop Z27, not all the way down so it goes into the well, just so you have a better chance of getting it in the well. So it's going to hover right over it. Then we're going to open the jaw once again to let loose of whatever candy you might have had. Then we're going to wait 2 seconds to make sure that candy falls out of there. With the G4, that's dwell. So we wait 2 seconds. Then we close the claw again, moving it E back to 0. We display a message on the screen that says, take your candy. Then we do a G28 to home once again, which really should only impact Z because we're already at X and Y where it needs to be. And then we play a series of tones. On this example, I'm playing 4 tones, and I've got a pause in between them, so it mixes up the tones just a little bit, so they don't just fly through rapidly. I put a dwell in each one of these to separate the tones out as I change frequency. Again, I would totally just create your own G-code script and run it over and over until you're happy with the tones that you've played. So we play 4 tones here. Then I tell M92 to turn all of the motors back to 0. This is steps, right? We turn off all the steps for all the motors just to make sure we're not going to go anywhere after we've completed the claw sequence. You couldn't if you wanted to, even if you wanted to move the joystick around. Then I put up the message on the screen, press start to play, because now we're at the end, we're ready for the next player to come up. And M77 to stop the print clock once again, so that when the next user is ready, they can hit start and it'll start working. That's pretty much all of the magic that you need to make those buttons work. If you want to edit something for your custom config, this is where you do it. Edit it in the button presses. If you need to know more about the custom buttons, again, there is a video on this subject just by itself. I'll leave a link in the description. Also, to the button description, I did not mention that. This is what's going to be displayed on the screen when you hit that button. So when you hit start, I say get that candy. And then when you're ready to claw, claw comes up on the screen. So be creative with that one. And then our final section here that we have to update is the joystick section. Now you want to take the comment off of this line so we can define it. This does support an analog joystick like the one we're using in this project. The clicky type that have 8 different positions on switches aren't going to work very well in this config. So you have to find an analog one that you can use. We're only concerned about X and Y. We did use a couple of analog pins on ramps, so we used 5 and 10. Again, you can see that in my diagram, or you can always check out the ramps pinout. You can see we use these right here, 5 and 10. And then we don't need Z or an enable button. So I just set those to -1. If you don't -1 the Z pin, the switch won't be pressed, so the joystick won't work. The default configuration wants you pushing a button down while the joystick is active, because it'll be active all the time if not. We have controlled this with our button presses up above with that start and stop clock to keep it from being active all the time. And then you have your joystick limits. X and Y are the ones that we're concerned about. We don't have Z in play here because we don't have a pin configured. But you need to enable joystick debug to be able to figure this out. I turn it off after I'm happy with how the joystick is set up, but I'm going to enable it and show you how to do this because this is a critical piece to get this to work. Not every joystick is going to be the same. So basically we are done with our configuration. This is all the stuff that we needed to set up to get our candy claw to work. But I'm going to go ahead and compile and flash this so I can show you how to interact with that joystick so you can get your settings correct. So our flash is complete. I'm going to open up Pronterface so I can show you how to debug that joystick. So like I said before, every joystick is going to be a little bit different. It's going to have different minimums and maximums. Fortunately, it's fairly easy to figure out. So if you do an M119 right now, it's going to show you all the end stops, but also your X and Y of your joystick, or Z and the enable button if you have those enabled. We're not concerned with that. I'll do my best to split the screen here, but so this is an M119, nothing has been moved. If I move over in the X and hit M119, you can see now I'm at a 28. Y is the same way, we'll go down. Now I'm at 16,000, 6,700 in X. And if you go crossways, same thing, 13,844. Back to the center. It's not always going to be the same every time, but you need good limits for this to work correctly. So if we go back to the configuration file, I've got my limits set to 0, 6,000 minus 100, 8,000 plus 100, these are the center points, and then 17,000 for max. These are the dead zones, so that it can set in the center and not think that it's moving. So you can have some allowance there. And you see that back in the terminal. Right now I'm at 6,000 X, 7,000, almost 8,000 in Y. If you didn't have those dead zones, it would currently be moving. And you don't want that. So what I can tell you is I would just go max X, see what that setting is, 28. So I'm completely fine with saying that's 0. Close enough. And then same way in the other direction of X, 15,000. So that's why I set it to 17,000. It's never going to get to that mark. You want to keep it somewhat close. 17,000 should be great. Same way for Y. So we'll go all the way down. We're set to 16,000. So again, I have it set to 17,000. We're fine. All the way up, 34. Close enough to 0, it's not going to matter. It's all about that dead zone in the center where it shouldn't be moving. So that's why these settings are here. We're close enough in between that 6 and 8,000. It's not moving at rest. But it knows its limits for X and Y, 0, 17,000, so that you can get complete mobility. You can get all the way up to speed when you're moving it around. You might have to play with it a little bit, but that's what that joystick debugging is for. So you can get the values and get them dialed in. Hopefully that makes a little bit of sense. If not, I could probably do a whole video on how this works on a 3D printer. But that's it. That's all you need to know to configure your firmware for your Candy Claw machine. And hopefully you can use this config and build from there. And that's it. We are done. This is the end of the Candy Claw series. Maybe. I do have a few updates that I would like to do to the machine just to make it a little bit more fun. Add a few things here and there, maybe change its size just a bit, but that will be much later. I'm going to study it for a while, see where I want to go with it, and maybe we'll come out with the official version 1.0 at some time in the future. Hopefully you liked this series, you liked all these videos, and you're having fun building your own projects. I will have everything updated. I'll keep it up to date out on the GitHub. You'll see updates come out if you want to follow that project. But that will be it for today. Hopefully you had fun with this one, and I'll see you really soon on the next one.